My name is Andrew. I'm a software engineer at Comcast. So I'll start today's presentation by talking about the importance of attributes in a tracing solution. And if you have been to the keynote, you have heard that semantic conventions is OpenTelemetry's proposed solution to address this issue. And building on top of OpenTelemetry's semantic conventions, I'll show how we were able to group together semantic conventions together with attributes used by our legacy applications. I'll also be sharing lessons we learned that help us stay the course. So let's start a little bit by talking about why we need tracing. I'm sure we're all convinced of this, but just to go briefly over it, let's say we have a client X that makes an API call to a front-end layer and receives the response back after 500 milliseconds. And suppose we wanted to know who was responsible for these 500 milliseconds. We all know that the front layer will be making calls to the back end, but we would have no visibility into the call stack. It's indeed a black box for which we cannot observe events that are taking place. So that's why we need tracing. It allows us to track a transaction journey. So let's go back to our example, and let's say the front layer will be talking to an authentication layer, which will be talking to an inventory layer, which will be talking to a database. And if they're all instrumented for tracing, the front end can then generate a unique trace ID that will be propagated to its entire call stack. Each layer will track its own work by using a span ID and send this information to the back-end tracing service, which, once it has all this information, it will help us visualize how the transaction took place, who is responsible for what part of the call. This is the importance of tracing. And from there, where do attributes fit? Let's say, I'm just giving a very contrived example. Please bear with me. Let's say the front end says that, oh yeah, the originator of this call is a client ID X. And authentication also agrees. It says, yes, it is client ID X. And the inventory layer too, yes, I agree with you. It's client ID X. But from this, you can already tell that if we don't have some common standards, at the time we go to the tracing end service and ask, give me information about X, we may need to do a query like this, right? This is extremely brittle. Imagine if a fourth component comes in and have its own idea of how to represent client ID. And imagine this multiplied across all these libraries and languages. What we are seeing is that tracing solutions, tracing platforms, inherently crosses domain of ownership. The front layer, authentication layer, inventory, they can all belong to different teams. And unless we have common standards, it'll be extremely hard, labor-intensive, to obtain value out of the solution that we're setting up. So this is where semantic conventions come in. It allows us to give common names for different kinds of operations and data. And I could have said better than they said, so I just copied this from their README. The benefit of using semantic conventions is in following a common naming scheme that can be standardized across a code base, libraries, and platforms. This allows easier correlation and consumption of data. And not just code base, libraries, and platforms. Any information about the attributes we can generate, schemas for database, documentations for developers. This can all become the outcome that we can get out of a semantic conventions. And how do we achieve that? Well, when we talk about semantic conventions, we're actually talking about a catalog of attributes. This is what the registry is. But together with this registry, we also have a tool called Weaver. It's an OpenTelemetry's project that can, based upon the target configuration files, take in the attributes and render out them in a format we can consume. So let's dive a little bit deeper into this. The registry is a repository in GitHub at that location. And under that repository, there is a model folder. And this is an example, like that we can see under the model folder, we'll have subfolders In each subfolder, attributes are grouped together. So let's say HTTP attributes. They will all be found under the HTTP subfolder. In this subfolder, there'll be multiple files, and the registry YAML file is the one in which we will find all the attributes listed, together with maybe the type, a brief description. So this is our catalog. This is our base, the set of attributes that have been defined by the community in OpenTelemetry. Now, let's talk a little bit about the target configs. Well, actually, we have an example of this target configuration file, say for Markdown, in this path. But before we show this example, let's take a little look at what this file does. It's a YAML file, and it will point us where the template files are located. It can help us also group attributes, filter out specific attribute we want to use as input. It also allows us to perform mapping. Say the type system used the semantic conventions may not correspond to the type system of the platform we want to use. So mapping is also supported. So there's a lot more options there's support. So this URL is where we can find more information about the configuration. So this, for instance, is an example of the configuration file for Markdown. In this file, we see template patterns. Actually, each pattern is a template file. It's in Jinja. The template is written in Jinja so that it can render out according to how we want it. So let's take a look at the first one. In the first one, it may be hard to read, but it's an attribute README. It's essentially the purpose of that file is to generate a README file that includes all the attribute groups. So you can see that the application mode is single. So this means that we take all the attribute groups as input and generate one single output file for that. However, we may want to generate separated, right? And this is the second pattern allows to do, the namespace template file. In this application mode, it will take one group and generate multiple output files. So this is what the config allows to do. It helps us manipulate attributes in groups and having outputs how we want. Then once those two elements are defined, we have the catalog, we have the configuration. Weaver, again, that's the location of the project, we'll take in those two and we'll look, okay, these are the attributes that I need to work on. And this is the configuration file that will tell me how I should render the Jinja. Then I'll do it. I'll take it and I'll render it out. And the Markdown can be rendered this way. And that attribute which we selected is rendered out as a row in the table. We can see that the type is shown and the brief descriptions opens up there. And this is what when we talk about semantic conventions, this is all included. It's all part of what we can achieve using semantic conventions. Now, we have many services for which they have started adopting the OpenTelemetry libraries. So they will be using semantic conventions. But again, in our company, there are some legacy applications for which this is not happening. But we want them to be part of our platform. We want them to be part of our journey together. So how did we do it? We have to put them attributes that they require and together with semantic conventions. Well, as I've shown you, the attributes are grouped under folders. So we actually take advantage of this fact and inject our namespace, our single namespace as a folder into the semantic conventions. This can be done in the local file system. We pull down the semantic conventions and we inject our namespace. And together, when we run the tool, we will generate a set of attributes that can be used by all our applications. So, and we do it exactly the same as semantic convention does. We have subfolders created for our specific needs, and we create target files. So this example that I have on screen is generating a schema in JSON for Elasticsearch. So in this example, for instance, we are excluding deprecated attributes. Our final outcome will not have them. We can filter those attributes out. Again, then we're also taking advantage of the mapping feature. The types supported by Elasticsearch are different from the type names used by semantic conventions. We can map them in a way that will be supported by Elasticsearch. So finally, we create the Ginger template file that will manipulate the attributes and create in the format that we want, obeying JSON syntax. And then final outcome then is this single JSON that we can be ingested by Elasticsearch to coordinate the schema, and also contains all the semantic attributes we want to use together with our in-house namespace attributes for our legacy applications. So in this way, we provide a single schema solution for our teams to use. Then what are some of the lessons that we have learned and how we envision this? Well, definitely, what single focus that we had from the beginning was we want to have a single source for trace attributes. Because again, if we don't have this common standard, it will be very hard for teams to come together and get value out of this tracing solution. But of course, we also needed to have a different format representation. Different parts of our company will need to access this information in different formats. We want to make sure that they are able to have it in the format they need, Markdown, YAML, JSON. And in this journey, with this focus, we leveraged all that we could. We learned Jinja very well. And just to give a few examples, like say you need attribute to be unique. Well, one thing that I didn't mention is that semantic convention supports, say, from a single group, reference an attribute from a different group. So if you're just purely rendering, the same attribute may show up twice. So we use Ginger to help us filter that out and create uniqueness. And as I mentioned before, the commas in JSON can also be handled in that way. So having this process in place allows us to create this registry. And teams that need different attributes can open PRs and insert their changes. And this is what we are doing as we currently migrate more than 3,000 microservices out of vendor that will remain unnamed. And definitely a very diverse set of teams. One of them, there are teams that they can take on the instrumentation libraries and use semantic conventions. And there are teams that they have their unique attribute needs for their visualization or learning. And having this schema strategy in place allows them to move at their own pace, right? Without having to stop their legacy application from running, which reduce migration friction, which is a very good thing. So how do we envision where we can go from here? Well, definitely we want to see maybe one day we can have the single schema across all observability signals. Create the most common set of attributes across all our signals. Take advantage of the power that it can give us. And also, it doesn't have to spread across all. We may create a subset of attributes as needed for specific application needs, right? Not everybody needs to have everything. So those are the elements that will be driving our effort in the future. And that's how we were able to achieve weaving together legacy application together with semantic conventions.